So we are going to start a new topic from the chapter chemical equation. So this is the next topic from the chapter chemical equation, that is chemical reaction and chemical equation. What is chemical equation? The method of representing a chemical reaction. The method of representing a chemical reaction with the help of symbols and formula. It is known as chemical equation. So this is zinc plus sulfuric acid. We represent zinc in the form of symbols. This is the symbol of zinc, and this is the formula of sulfuric acid, H2SO4. This is the formula of zinc sulfate. This is the formula of zinc sulfate plus hydrogen gas, that is H2. We represent this whole chemical reaction in the form of symbol and formula. This is the symbol and this is formula. When we represent the chemical reaction in the form of symbols and formula, that is called chemical equation. So we represent the chemical reaction in the form of symbols and formula, that is called chemical equation. Now the left hand side part, this is the left hand side part, this is the left hand side part of the chemical reaction is called reactant. The left hand side part of the reaction is called reactant, and the right hand side part of the reaction is called product. This is the right hand side part of the chemical reaction is called product. This is the left hand side part and this is the right hand side part of the chemical reaction, and the left hand side part of the chemical reaction is called reactant, and the right hand side part of the chemical reaction, that is called product. What is balanced chemical equation? What is balanced chemical equation? The balanced chemical equation has equal number of atoms in the left hand side. Left hand side, equal number of atoms on the left hand side and equal number of atoms on the right hand side. That is called balanced chemical equation. Equal atoms, equal number of atoms on the left hand side, equal number of atoms on the right hand side. That is called balanced chemical equation. Like we discussed in the next example, zinc plus sulfuric acid, zinc sulfate plus hydrogen gas. How many atoms in the zinc on the left hand side? That is 1. How many atoms in the left hand side in hydrogen? That is 2. How many atoms on the sulfur side? That is 1. How many atoms on the oxygen in the left hand side? That is 4. How many atoms in the right hand side in the zinc element? That is 1. How many atoms in the sulfur on the right hand side? That is 1. How many atoms in the oxygen element on the right hand side? That is 4. How many atoms in the right hand side of hydrogen? That is 2. So the atoms on the left hand side, atoms on the right hand side are equal. So we can say that this is a balanced chemical equation. Now we will further discuss unbalanced chemical equation. What is unbalanced chemical equation? Has unequal number of atoms. On the left hand side atoms, left hand side atoms is not equal to right hand side of the atoms. So when it is not equal to, we can say that it is unbalanced chemical equation. When the left hand side in the reactant side atoms not equal to the atoms on the right hand side. We will further discuss on the basis of example how many atoms on the hydrogen in the left hand side, that is 2. How many atoms in the oxygen side on the left hand side, that is 2. How many atoms on the right hand side in the hydrogen case, that is 2. How many atoms in the oxygen side, that is 1. So the left hand side of the atoms are not equal to the right hand side of the atoms, that is called unbalanced chemical equation. Unbalanced chemical equation. So we will discuss on the basis of next example. Now we will try to balance an unbalanced chemical equation. We will discuss H2 plus O2 equals to H2O. In this is left hand side, this is right hand side. And how many atoms in hydrogen? That is 2. And how many atoms in the oxygen side on the left hand side? That is 2. And how many atoms on the right hand side in hydrogen? That is 2. How many atoms in the oxygen side? That is 1. So what should we do? This is H2 plus O2 and we have H2O. What we will do, this is oxygen have 2 atoms. This is oxygen has 1 atom. We have taken 2 here. So we have taken 2 here. Now oxygen has 2 atoms. So oxygen has now 2. What is 2 multiply 2? That is 4. 2 multiply 2, that is 4. But hydrogen has 2 atoms on the left hand side. So we have taken 2 here. 2 multiply 2 is 4. So now hydrogen is 4 on the right hand side and hydrogen is 4 on the left hand side. Now it is balanced chemical equation where left hand side equals to right hand side. Okay, so this is now a balanced chemical equation. Now we will further discuss on the basis of equation will be more informative by indicating the physical state of reactants and products. How can we discuss the physical state of reactant or products? We have an equation of chemical reaction zinc plus sulfuric acid, zinc sulfate plus hydrogen gas. What is zinc? This is solid. What is sulfuric acid? This is an aqueous solution. What is zinc sulfate? This is also an aqueous solution. What is hydrogen? That is gas. This aqueous, gas, solid, this indicate a physical state of reactants and products. This indicate a physical state of reactant and products. If we need more information of chemical reaction, we need to represent what is zinc, what is sulfuric acid, what is zinc sulfate, what is hydrogen gas. So we will represent this on the basis of indicating a physical state: aqueous, gas, solid. Like we will discuss further in the next example. This is a slaked lime calcium hydroxide. What is calcium hydroxide? This is aqueous solution. You will need to represent aqueous in front of CaOH2. What is carbon dioxide? This is a gas. What is calcium carbonate? This is a solid. What is water? That is liquid. So this is indicating a physical state of reactants and products. Now we will further discuss to indicate the heat change in chemical equation. What is indicate a heat change in chemical equations? Some chemical reactions releases the heat energy. Some chemical reaction absorbs the heat energy. Those reactions in which heat is released or evolved, that is called exothermic reaction. Those reactions in which heat is evolved or released, that is called exothermic reaction. Carbon plus oxygen, if we burn carbon in air, it forms carbon dioxide gas and a lot of heat energy is released. A lot of heat energy is released, so it is a exothermic reaction. Carbon plus oxygen, it becomes carbon dioxide and lot of heat energy is released. So that is called exothermic reaction. Now we further discuss another example, methane gas. When any natural gas burns in air, it forms carbon dioxide and water vapor and lot of amount of heat energy is released. So it is an example of exothermic reaction. What is methane gas? That is CH4. What is oxygen? It is 2O2. It becomes carbon dioxide, water vapor, and lot of heat energy is released. So we can say that it is a example of exothermic reaction. When a lot of heat energy is released, it is a exothermic reaction. All the combustion reactions, all the combustion reactions, when we burn in air, all the combustion reactions are exothermic reaction. All the combustion reactions are exothermic reaction. Another example we will discuss on the basis of exothermic reaction, that is rest. Next is we need energy to stay alive. How we will get this energy? When from the food we eat. During digestion, food is broken down into simpler substances like the food like chapati, bread, rice, potatoes. They have carbohydrates, starch. When the carbohydrate starch is broken down into simpler carbohydrate, that is glucose. Glucose, when undergoes slow combustion by combining the oxygen in the cells of the body, we breathe, we inhale oxygen, and that oxygen slowly reacts with glucose to produce energy. To produce energy, that is called respiration. Glucose burn in air, oxygen. It becomes carbon dioxide, water, and energy. So that is lot of heat energy is released. It is called exothermic reaction. So respiration is an exothermic process when a lot of heat energy is produced during that process. Yesterday we have discussed the burning of magnesium wire in air to form magnesium oxide. That is also an example of exothermic reaction. Now we discuss endothermic reaction. When the lot of heat energy is absorbed, when the lot of heat energy is absorbed, that is called endothermic reaction. This amount of heat energy is absorbed on the left hand side of the reaction, that is called endothermic reaction. All the decomposition reactions are called endothermic reaction. or the decomposition reactions are called endothermic reaction. Like we have an example of calcium carbonate. We break calcium carbonate, we decompose calcium carbonate in the form of calcium oxide and carbon dioxide gas. When we decompose this, a lot of heat energy is absorbed, that is called endothermic reaction. Another example we will discuss on the basis of endothermic reaction, we have electrolysis of water to form hydrogen and oxygen, that is also called endothermic reaction. Another example, indicate the conditions indicate the conditions under which reaction is takes place. What is the condition? The heat signal delta. This is the heat signal delta. This is the condition under which the reaction takes place. Sometimes we use the catalyst. This is also a condition. Sometimes we use heat. That is also a condition. So potassium chlorate decompose when we heat this reactant, it becomes potassium chloride and hydrogen gas. And this is a condition. This delta is a heat. It is a condition on the basis of this chemical reaction occurs. Next example is methanol. Methanol, we have taken the pressure. This is the pressure. It is a condition at 300 atmosphere. This is the temperature, 300 degrees Celsius. This is the pressure, this is the temperature. On the basis of that, this chemical reaction occurs and we have a product. This is called a condition of this chemical reaction. Like next condition is photosynthesis process. So the photosynthesis process, on the basis of condition, we have sunlight and that leaf traps the solar energy. It has green pigment chlorophyll. So on the basis of this condition, this chemical reaction occurs. On the basis of this condition, this chemical reaction happens. That is called the condition on the reaction takes place. So we have today discussed conditions of the reaction takes place, endothermic reaction, exothermic reaction. On the basis of we have discussed physical state of the reactants, what is balanced chemical equation, unbalanced chemical equation. So yesterday we have discussed the introduction part of chemical reaction. Now we have discussed furthermore balanced, unbalanced, exothermic, endothermic, indicate the factors on which reactions takes place. So I hope you understand the whole topic.